Yeah, good evening. In the last videos, sir, we are talking about asymptotic notations. Okay, so what is the main purpose of these asymptotic notations, which is used to measure or represent time complexity of any algorithm? We need to go for these notations. Sir, how many notations are there? We have five notations are there. The first one is nothing but big O notation. The second one is nothing but omega notation. The third one is nothing but theta notation. So fourth one is nothing but little o notation and little omega notation. Like this we have. So anyway, we are going to concentrate only on, okay, we are going to concentrate only on first three: big O notation, omega notation, theta notation. Sir, it is something related to the mathematics. That's why, so please concentrate, sir. Okay, please concentrate. Sir, what is the first one here? Big O notation. Sir, what is this big O notation? Okay, symbolically it is represented as capital. Sir, there is one format is there. Okay. Sir, a function f of n is said to be a function. Yes, f of n is said to be okay. So said to be in big O of g of n. Big O of g of n. Like this, we have to represent. Sir, denoted by f of n is equal to big O of g of n. Like this, we will represent. E is bounded above by, okay, he is bounded above by, sir, some constant, okay, above by some constant. So multiple of g of n, okay, sir, something like if you multiply g of n with some constant, then that function will reach to above f of n, okay, for all large values of n, or for all n, I can say like this. That is, so there exist a positive, there exists a positive constant c value, a positive constant c, and a non-negative, that means positive value, sir, non-negative integer n naught, integer n naught, such that, so f of n is less than or equal to that constant value into g of n. Okay. So for every n is greater than or equal to n naught. This is the definition, sir. Okay. So how you can able to represent big O of n? A function f of n is equal to big O of g of n. When it is possible for f of n, it should be always less than or equal g of n for some constant c. If you multiply with some constant c, sir, it is always less than or equal to g of n for every n value which is greater than n naught. So once if I take the diagram for these, you people will get a clarity. Okay, then you people are going to get confused because of this. Sir, I am going to represent. So which diagram here? So I want to represent big O notation. Okay, big O notation. This is a diagram I want to represent. Sir, what is the formula? Your f of n is less than or equal to some constant into g of n. Sir, where that n value is greater than or equal to some constant n naught. First, if you open the diagram, then you people will get some clarity. Sir, I will draw this diagram. Have a look once how it will be. So here I'm going to take, okay, I'm going to represent the diagram in this style. So this diagram, better I will take, yes. So that a diagram is nothing but having two axes. One is nothing but x axis, another one is nothing but y axis. Let us consider like this. And here I'm going to draw the diagram. Okay. So consider this one is nothing but f of n. Okay, this one is nothing but something like f of n. I will take like this. This one is nothing but something like f of n. Just Yes, I can take like this. And your g of n is nothing but here like this. Like this. Sir, here I am going to represent these in words. This one is nothing but g of n function, and this one is nothing but f of n function. Sir, if you observe clearly, g of n is starting from here. Okay, your g of n is starting from here. F of n is starting from here up to certain point, sir. Once if this point got reached, then what is happening? G of n is higher when compared with f of n. Okay, when compared with f of n, g of n is increasing like anything. Sir, this point is called as, I can able to say, n naught. At a certain point of time, automatically what will happen? Sir, your g of n will become increase when compared with f of n. If such type of function if you are getting, then we can say f of n is equal to, f of n is nothing but f of n is less than or equal to, sir, some constant of g of n. Sir, this one can be represented in this style. Okay, f of n is equal to big O of g of n. If any functionality if you are getting in this format, then this is considered as big O representation. Okay, sir, I request everyone to please be on mute. Ashok Patil. Right. This is nothing but what we have, sir. Okay. Sir, I think you got clarity about this diagram. Okay. Sir, I will take example, then you people can understand well. Sir, I am taking f of n is equal to, sir, something like 2n plus 2 I am taking. Okay. So, g of n is equal to, sir, I am taking n square, n square. Assume it is n square. Like this, I am taking. Okay. Sir, where? We have to provide the value of n. Okay, we have to provide the value of n. So I will take this n later, but let us construct that formula here. Sir, what is the f of n value they have given? The f of n is equal to 2n plus 2. Okay, sir, your g of n is equal to n square. Like this they have given. Now, let us substitute n is equal to 1. What will happen? Sir, your f of n will become, this is f of n, and consider this is g of n. So, what will be the value of f of n when n is equal to 1? Sir, 2 into 1, 2, 2 plus 2, 4. Sir, what is n square value? 1. So, when n is equal to 2, sir, what is happening? 2 into 2, 4. 4 plus 2 will become 6. Okay. Sir, 2 square will become 4. So when n is equal to 3, okay, when n is equal to 3, sir, why you people are making noise? So I'm muting every participant, sir. That because of someone, rest of the people are unable to ask the doubts. So when you are attending the class, please make sure that you are in mute or not. Okay. So when n is equal to 3, what is the f of n value? 2 into 3, 6. 6 plus 2 will become 8. Sir, 3 square. What is the 3 square value? 9. So when n is equal to 4, sir, what will be the value? 4 into 2, 8. Sir, 8 plus 2 will become 10. Sir, what about this? Is it 16 or not? Yes. Sir, I think you can able to observe from here. Sir, is f of when well, n value is always less than or equal to g of n or not? Yes, drastically the values are going to increase. But when n is equal to 1 and n is equal to 2, we can't able to make the decision. Sir, what will be the value of n here? Okay, sir, where the value of n is greater than or equal to 3. Okay, when the value of n is greater than or equal to 3, these functions are going to be increased like anything. If such type of things will come into the picture, then we can say f of n is equal to big O of g of n. Okay, at certain point of time, drastically that function has to increase the values. Sir, how it is related to time complexity? Because in the background, so everything is calculated in the form of functions. Just to try to understand these theoretical points. Sir, in this example, what will be the value of n? N is greater than or equal to 3. Like this, you can take any number of functions f of n one function, g of n one function, then that f of n is big O of g of n or not, we can able to calculate by using these functions. Sir, you can able to see these kind of complexities already we have seen. So where n indicates number of iterations, in the same way it will be there, sir. It will be calculated in the form of functions. Okay. So now I think you got at least some clarity about this big O notation. Can you please confirm? Do you have any doubts in this big O notation? Yes, everyone, please confirm. Yes. So don't get confused, sir. Just it is a mathematical formula. Remember like this only. Clear up to this? Any doubts? Please confirm everyone. Diagram here you can able to see, Mr. You can able to see from here. Okay. Sir, up to certain point. Sir, where this f of n is available from here, f of n is leading at the top. G of n is down value. Sir, up to certain point, that is nothing but n naught. Once if n naught constant value is reached, drastically the value of g of n is rising when compared with f of n. So when compared with f of 1, if you are getting g of n in upper bound, then we can able to say f of n is equal to big O of g of n. Suppose if f of g of n is coming downwards to the f of n, then it is called as the next thing that we will discuss later. Okay, sir, hope you got clarity. Who asked this? Vidya, clear? Kiran Kumar. If g of n never crosses f of n, then we can't able to give this big O notation for that functions. Clear? Sima, there is no guarantee that g of n is initially less. There may be g of n starting from 1 itself drastically can increase. See, functions means what? If you substitute some values, we have two functions are there. So first function result will be something, second function result will be something. Suppose if g of n function result is more when compared with f of n drastically, continuously, then we can say f of n is equal to big O of g of n. That is a theory what we have. So for that, we are identifying that delimiter from where it is going to increase. That point we need to observe. From that point, it will drastically change. Clear? Any constant value. Here, constant value is what? 3, right? Yes, we need to consider from this intersection point alone. From here, we need to consider. Because these never met. Always g of n is greater when compared with f of n from these values. Before these values, we can't give. Sometimes maybe upper, sometimes maybe lower. We can't give guarantee. Clear? Right. So this is nothing but what we have. Sir, which one it is? Big one notation. Sir, next one, I am going for the next notation. What we have here is, sir, what is the next notation that we have? Sir, omega notation. Okay, what is the next one? Omega notation. Sir, just for our understanding purpose, I will take a W. Okay, so we can't represent with the help of W, but just for our convenient purpose. Sir, I can copy paste this as it is. Sir, what will be the definition? A function f of n is said to be omega of g of n. Omega of g of n denoted by f of n is equal to omega of g of n if, okay, so f of n is bounded not above, okay, bounded below, okay, bounded below by some constant multiple of g of n for all the values of n. That is, if there exists a positive constant value c and some non-negative integer n naught such that f of n is greater than or equal to g of n. So for all the values of n is greater than or equal to n naught. Sir, can we take the diagram here? Yes. Sir, the diagram will be same almost whatever we have covered for previous. Sir, what changes will be there? So consider this is nothing but x-axis and this is nothing but y-axis. So here we need to represent. So maybe let me take this function as a g of n. Like this, just a slight change I am taking. Okay, like this I am checking. Okay, no problem. Okay, let it be. Sir, now I am taking f of n. Okay, so I am taking f of n. So f of n can be like this. Okay, no problem. Yeah. So consider this function is nothing but f of n. And what about this function? Some constant into g of n. Some constant into g of n. Sir, where the values are increasing simultaneously, this value is called as n naught. Sir, up to this we can't able to predict. But once if this constant got reached, okay. So once if this constant got reached, sir, in previous example, f of n value is low when compared with g of n. Sir, we need to talk always with respect to g of n. In previous case, g of n values are increasing, but here g of n values are decreasing. Okay, that is the point. So here I can able to say f of n is equal to, sir, omega of g of n. Okay, omega of g of n, sir, where n value is greater than or equal to some n naught. We need to calculate that n naught based on the functions. Okay, so this is nothing but the diagrammatic representation of this omega notation. Sir, can we take any example? Like I want to take f of n is equal to f of n is equal to 2n square, okay, plus 3. So g of n is equal to something like 7n. Okay, sir, where we need to find out the value of n naught, for which values it is going to change. So let us take these functions and we will cross check how it is going to work. Now let me take so f of n is equal to, sir, what is the function they have given? 2n square plus 3. Okay, so 2n square plus 3, and so your g of n will become 7n. We need to trace out. Sir, when n is equal to 1, what is the f of n value? Sir, 1 square, 1, 2 into 1, 2, plus 3 is nothing but 5. Sir, what about g of n? It will become 7. So when n is equal to 2, sir, what about f of n? So 2 square, 4, 4 into 2, 8, 8, 9, 10, 11. Sir, what about g of n? So 2 means 14. Like this we are getting. So when n is equal to 3, sir, 3 square, 9, 9 into 2, 18, 19, 20, 21. Sir, 7 into 3, which will become 21. Sir, if you take n is equal to 4, 4 square, 16. 16 into 2, 32. Sir, 32 plus 3, 35. 7 into 4, 28. Correct? Now, sir, when n is equal to 5, so 5 square, 25. 25 into 2, 50. 53. Here, 35. Sir, now you can able to see here. Sir, just wait for 1 minute. So please wait for 1 minute. Please wait. Yeah, right. Sorry, sir. Yeah. So let's continue. Sir, here you can able to see. Sir, are you seeing here n when n is equal to 1? Sir, this value less than or not? Yes. Sir, when n is equal to 2, this value is less than or not? Yes. When n is equal to 3, this value is equal. Sir, when n is equal to 4, this value will become greater. Sir, this value will become greater. That means from here, I can say, sir, n value is greater than or equal to 3 means I can able to say f of n is equal to, sir, omega of g of n. So this comparison is required. Okay. From n is greater than or equal to 3, the value of g of n is going to be lower bound when compared with f of 1. Sir, now you can take any value. Sir, definitely this equation is going to be satisfied. Okay, but we can't give guarantee for n is equal to 1 and 2 because, sir, we calculated. From here only, the value is going to be increased. This point, this cross point is nothing but this one. Okay, I hope you got very clear clarity about this omega notation. Sir, can you please confirm? Do you have any doubts in this omega notation? Everyone, please confirm. Yes, I request everyone to please confirm. Clear? Yes, Vishal, your answer is correct. N is equal to 4. Okay, but for n is equal to 3, it is equal, right? From there, it will be drastically changing, increasing. See, time complexity, we are not calculating here. For time complexity, we are following some theoretical calculation. That theoretical calculation I am explaining. Okay. Yes, inclusive values, Vishal. In all the cases, inclusive values we have to take. Because that intersection, right? So there the point is meeting. That meeting point onwards, changing values we have to find out. Before that, we not required. Yes, diagram is not predefined. You can write like anything. You can write like anything based on your convenience. But in that diagram, what you need to observe in that diagram, suppose if you are taking for omega notation, if you are taking for omega notation, you can take like this also. So for g of n, you can take like this also. But from here, if any meeting point is there, from here g of n should fall down, f of n should be above. So up to this, you can take in any style, no issue. Clear? So that is the meaning of that equation, right? Right. So let us go for the next notation, which is nothing but sir, theta notation. Sir, I can't able to represent the diagram, but just for our convenient purpose, I am taking 0. Okay, because in this font, it will be something like theta only, right? Now, sir, let us take this definition as it is. Only changes is nothing but that functions and values like that. Sir, a function f of n is said to be theta of g of n denoted by, sir, f of n is equal to, sir, theta of g of n is bounded with above. Okay, is bounded so with above and below. Okay, both values by some constant multiples of g of n, constant multiples of g of n for all n. That is, sir, there exists a positive constant. So C1 and C2. There exists a positive constant C1 and C2 and some non-negative integer n naught such that your, sir, C2 into, okay, sir, C2 into g of n will be always less than or equal to f of n is always less than or equal to c1 into g of n. Okay, like this we have. That means what? Sir, your f of n should lies between two g of n's. Okay, your f of n should lies between two g of n's. Okay, that is the meaning. Sir, I will take example later, but before that, let us look into the diagram, how it will be. Sir, here I am going to take a diagram in this step. Sir, how many values will be there here? So there will be multiple values. Let us take this one is nothing but sir some value, and here I am going to take one more representation. Let us take in this style like this, and I want to take one more value like this. I am going to take right. So here I can say this one is nothing but some meeting point. Oh my God. Yes. Sir, are you seeing from here? I can say this one is nothing but f of n. Okay. So this one is nothing but I can say so constant 2 into g of n. Sir, this one is nothing but constant 1 into g of n. So your f of n is lies between these. Sir, even this diagram is wrong. So I think we need to take in this step. So this value drastically it is going to increase. Okay. So that means the value of f of n, the value of f of n is going to lies between these. Okay. So here you can able to observe up to certain constant, it can be like anything. But once if that constant value got reached, sir, your f of n should be always in between c2 into g of n, c1 into g of n. Okay, less than c2 into g of n, greater than c1 into g of n. Sir, less than c2 into g of n, greater than c1 into g of n. It should lies in between this. Sir, let us take one example so that we can able to understand well. Okay, we need to understand well once if you take any example. Sir, let us take I am considering f of n is equal to something like 2n plus 8, and g of n is equal to something like I am taking n. Let us check how it is going to be validated. Sir, let us take your f of n is equal to something like 2n plus 8. Okay. So your g of n is equal to n. Like this I have. Sir, I will check with all the values of n. Suppose if n is equal to 1. Sir, what is the f of n value? What is the f of n value? Sir, 2n, 2 into 1, okay, which will become 2. 2 plus 8 is nothing but a 10. Sir, what about g of n? Yes, please wait. Yeah, what about g of n? It will become 1. Sir, for n is equal to 2, what about f of n? Sir, 2 into 2, 4. 4 plus 8, 12. What about g of n? Sir, it will become, sir, when n is equal to 3, okay, when n is equal to 3, sir, 3 into 2, which is nothing but 6. 6 plus 8, 14. Sir, what about this one? 3. Okay. Sir, this one is drastically increasing. So this one is also increasing. 1 minute. I think we need to take some other constant. From that we can able to get. Just a second, sir. Better I will take some other. What value we can substitute in the place of C1 and C2? Sir, please wait 1 minute. We can frame this actually for which values it will change. Okay, I will change the functions. Even it will work, but 1 minute, I will change the function. So let us consider the function. Yeah, it will work, but yeah, that's what. Just I'm changing the values. Yeah. So let us consider f of n is equal to, sir, 4n plus 1. Okay. So g of n is equal to, let us take n, but I am going to represent C1 value as a 4 and C2 value as a 5. That will be fine. Now you can able to check. Sir, now I am taking n is equal to 1. Sir, what will happen if n is equal to 1? Sir, first I will check f of n. Otherwise, I will check C2 into g of n first, and then f of n, and then C1 into g of n. Like this I will check, because it will lies between these two. Sir, when n is equal to 1, what will happen? C2 into g of n. C2 value is nothing but a 5. 5 into 1, 5. Sir, C1 into g of n. Sir, 4. What about f of n? Sir, 5. Right? Sir, when n is equal to 2. Sir, what will happen when n is equal to 2? What will happen? Sandeep, is it required now? Please cross check. First, listen the class. When n is equal to 2, what is happening? Sir, you can able to see C2 into g of n. 5 into 10. 5 into 2, which will become 10. C1, 4 into n. 4 into 2, which will become 8. Sir, what about f of n? Have you observed here? Sir, 2 into 4, 8. 8 plus 1, 9. So even when you are taking n is equal to 3, sir, 5 into 3, 15. 4 into 3, 12. Sir, 3 into 4, 12 plus 1, 13. Have you observed here? I think from here itself, we can able to see, sir, C2 into G of n is greater, okay, when compared with f of n, and it is greater when compared with G of n. Sir, is it correct? That's all. So now we can say f of n is lies between. So which values? Sir, C1 into g of n is less than or equal to f of n is less than or equal to C2 into g of n. Like this theta notation is going to be represented. Okay. Sir, you can able to see your f of n value is lies between these values. Okay. Sir, clear up to this? Yeah, in theory it is written reverse. Yes, correct. So first we have to take C1 into G of n. So is less than or equal to C2. So what is the function that we have taken here? 4n plus 1. So 4n plus 1. And here it is a 1, where C1 is equal to 4 and C2 is equal to 5. Okay. And what about n value? Sir, where n is greater than or equal to 1. I hope it is very clear for you, right? Sir, do you have any doubts in this theta notation? Please confirm. Sir, requesting everyone to please respond. Yeah, that depends on function. You can take any function and you can check it. So if the function is mapping, then only you have to consider that expression. Otherwise, you have to look for alternative. Such a type of functions only will satisfy. For taking the functions, we don't have any syntaxes. Clear? Right. So this is nothing but what are asymptotic notations we have. Sir, small omega notation, small o notation, I am not going to take. Even those things are not important as of now. Okay. So this is nothing but how you can able to represent these notations. Okay. See, you can take that 4n plus 1 for g of n and calculate whether that equation is satisfied or not. If that equation is not satisfied, we can't able to do. Okay. Right. Okay, sir. So thank you. Sir, tomorrow we don't have any session. The next class will be on Monday. Okay. So Monday we are going to start a new topic called recursion. Okay. Yes, thank you. Yes, sir. Updated running notes will be updated daily. Definitely, because here, see, Manoj, we can take f of here, we can say theta notation is a combination of big O notation and then omega notation. Definitely, because f of n is less when compared with some function. F of n is greater when compared with some function. Okay, so in that point of view, suppose if f of n is drastically changes like this, then you can't consider this one as a omega notation, I mean theta notation, but it will be some other notation. Based on that, it will be clear. Yeah, I will update notes and video, I mean diagrams also, don't worry. Kiran, I will explain that, don't worry. Yes, yes. Sir, logic based programming doubts, why you are asking here? Logic based programming class is at what time? UK. Can you please tell? At what time logic based class is there? Same timings will be there. Okay. No idea now. At what time you have registered?